What's up everyone and welcome to another video, and in this case a new project that we are going to be building together today. Now you might be wondering what the project is. Well, let me show you. What you can see on my screen is a map along with university rankings. Now these are rankings of the top universities in the world for the year of 2021. What you can probably notice by now is that we have a search box, we have some rankings, and this map, which is a map powered by Google. And if, for example, I go ahead and I search for something, so let's assume I want to find all the universities in Poland because that's my home country. If I type in Poland, as you can see, the search results are almost instantaneous. Well, they are actually instantaneous. The time it takes is up to 100 milliseconds per request. And what you can see is all the universities in Poland, their specific rankings for the world, and of course, a marker for each university in Poland. I can search for other universities. So if I type in India, well, then I get all the universities in India, for example. And if I go ahead and I search maybe for a specific university, the one I went to, which is University of Kent, if I type in University of Kent, well, there you go. It automatically zooms in directly to that one university where I went, of course. And it says that the world ranking is 315, which I assume is pretty good, but nothing comparable to obviously Oxford, Cambridge, and all of the rest of the world. Now, this is very cool. And as you noticed, highlighting that point again, it's instant. Everything happens instantly. There is no delay, there is no wait time, and this gives beautiful user experience. Not only that the map is cool because it zooms into those specific locations, which I think is really fancy, but also it filters those results, and you can have a lot of information with filtering results like this. So that's the kind of project that we're going to focus on today. So make sure you guys get your laptops ready, grab a cup of coffee, and let's jump right into it. Now, for you that may be wondering what you might learn today in this project, you're going to learn how to use Algolia. You're going to learn how to manipulate JSON data and add data to specific JSON objects that already pre-exist. You're going to learn how to connect to specific APIs, and you're going to learn how to implement widgets that are provided by Algolia in this case, how to edit them, style them yourselves, and then of course how to manipulate that data that you have sent over to Algolia to filter for specific attributes or to rank, for example, in this case, universities, to make sure that it always shows the top university in your current search query. So this is really an awesome project that you can get involved in and learn some really cool stuff. And in this case, some latest technology that a lot of really big stores, e-commerce stores, and known brands use on their websites to really give a great user experience for filtering and finding the stuff that you might need. And this is just a very simple example. The possibilities span way above this. So I hope you guys enjoy, and let's dive right into this project. What you can see on my screen here is a Webpack starter. Now this is a private repository I have on my GitHub, which I'm still kind of working on, and I plan on making public very soon for you guys to use. And of course, maybe I'll speed that up if this video gets a lot of likes. But this is a starter that I'm going to be using, which is basically a bundler that already has React integrated into it for just really easy start of projects. And in this case, React projects, but of course you can use it for any other technology because the bundler works in the same way. So I've already cloned this project into my direct local repository, and I've made some changes that I'm going to kind of explain to you guys as of now to give you guys an overview of what the project structure looks like. So if I just go into my Webpack starter, this is the project that we're working with. So we have our bundler, which has different environments, but this is not relevant at this point. We have our node modules because I already installed all the modules that I declared in this bundler that we're going to need to get the project started. And the most important part is this source code folder where we have our components, which is our starter project. So if I actually run this in the web by running npm run dev, And we'll wait for this to launch, and it should just launch automatically and take you to the web page. What you can see, it's my developer Filip starter React project that hopefully you guys will have available very soon for you guys to use. Now, of course, going back into Visual Studio Code, continuing on, I also have a JavaScript folder where I happened to already include all the university rankings for 2021 as a JSON object. Now, this is something I found on Google. If you just type in the search bar, World University Rankings 2021, you'll get a few links where a website gives you the ability to download this JSON file. Well, actually to download this information as a JSON file or in the format of a CSV, which you can just use. So I just downloaded it and I put it right into my application because we're going to need to manipulate this data. We have the rankings of every university. We have the name of the university. We have the location where it's based, number of students, student to staff ratio, percentage of international students, gender ratio. But there's one property here that we are missing. Can you guess what it is? The property that we're missing here is our geolocation property, and that's the latitude and the longitude of those universities. And that's the kind of data that we're going to need to be able to run through the project and showcase all these markers on the map. So to actually visualize this data on a map. So in order to get this geolocation data, we're going to need to do some clever stuff. So in this case, I've created the geolocation.js file, which imports those rankings into this file. I import Axios, which is a library for doing requests to an API. And then I import the file system library, which is a library that will allow us to save all our new data to a new JSON file and use that JSON file later on to send over to Algolia. Let's get started with actually writing some code to be able to search through all that current data that we have for the university rankings, and for each data, add the geolocation. Now, it might seem that it's quite difficult because where do we get that geolocation from? Well, that is a great question, and I have a great answer to that question. Where you can get the geolocation from is by using the Google API, which is called the Geolocation API. Now, of course, if you want to be able to use the Google APIs, you're going to have to register on their Google Cloud Platform, and you're going to have to create an account and enable those APIs, and then get your API key to be able to use them. I'm not going to go into the details of how to do that. If you want, just make sure you write it in the comments for me to do a tutorial on how to get those and enable those APIs. But in this case, we're going to be using the Geolocation API for this project, as well as the JavaScript Maps API to be able to render that map and actually showcase the results on a map. So those are the two APIs that we're going to need. The Geolocation API is an API that gives us the functionality of converting any named location, so any named address. And in this case, it can be the actual physical university name, which is a string, and to convert that string into a geolocation. So the latitude and the longitude of that place. We're going to have to use that API, and there's certain things that I'm going to have to tell you once we get to it, so bear with me. But for now, let's actually write a piece of code to get all that JSON data, send specific data over to that geolocation API, in this case, send the title, and then retrieve the result and append that geolocation, latitude and longitude onto that specific object, just each individual ranking of each university, and then save all of those rankings together and put it into a new JSON file. Right, so the first thing that we need to do is iterate over that whole JSON file. And for each one of those objects, we need to send an API request over to Google Geolocations with that title inside it, and retrieve back the coordinates. So we'll get back a whole response, and within that response, we're going to find those coordinates. Now, one thing I do need to mention is that when we're sending over the string, which is the name of the university as a string, it has to be encoded. So all the blank spaces will have to become percentage sign 20, just so Google understands that specific case scenario. So let's start and write a function called constant get coordinates, if I can spell that correctly, coordinates, like so. Now I'm going to be using fat arrow functions because that's the thing to do nowadays, if you want to be bougie like that and fun. Okay, so we're going to get the coordinates. Now, every time I iterate over the list, I'm going to have to store that new object somewhere. So I'm going to create a Geo Universities constant, and I'm just going to assign an empty array to it for now. Now here comes the whole process of actually iterating over that data. So we've got our data called rankings, and what we're going to have to do is rankings dot map, and then here we can provide a function. I'm just looking to the right because I have my whole guide for this code just to make sure I don't make any mistakes. If you see me looking over, don't worry, it's just me making sure that I know what I'm writing exactly. Now, in this case, we're going to create a function with fat arrows once again, and inside this function we're going to iterate over the rankings, and here we're going to look at each specific ranking, and we're going to pass in the index just to make sure that we can keep track of all the objects that we iterate through. Now what we can do is whenever I write functions that fetch an API, I do a try and a catch. I wrap everything in a try and a catch with an exception to make sure that there is no faults, and to make sure that I catch everything. So here we can just console log the error. So if anything happens, we're going to know that what the error is. Now in the try statement, I'm going to do a const response equal to axios dot get. And here we're going to pass in the URL that we have to call for that specific API. And that's our response. Now let me copy that URL so I can actually paste it in here, the one that's relevant, like so. And as you can see, I've already copied the encode URI component. So here we have split the string, and then inside it, because the ranking.title is an attribute that we pass in that's going to change, so we refer to the ranking.title in this case, because that's how our object is created, ranking, and it has the title. So this object we call as ranking, and then we refer to that specific title. And as you can see, I've wrapped it in encode URI component. Now this is already a pre-built function with a JavaScript that you can use, and you can just directly call and pass in whatever you want to encode inside it, and that's going to take care of that encoding those blank spaces to make sure that this request actually goes through. Now the problem here with this request is that it's not going to work, and the reason it's not going to work because every time we're placing calls to an API, we want them to be asynchronous. Now, of course, we can declare this whole function that we're iterating over because this is a function inside of functions. We're focusing on this function inside the map. We can specify it as being asynchronous, and to make sure that our requests go through and we get a response back, because if we did it without the asynchronous and await call, the response might never come back. We have to await for this request to complete. So now we're iterating over a map of different JSON objects, and then we're placing an API call with axios as an asynchronous function, and we're awaiting for each response to come back. Now with each call, we're going to get a response, and we have to dynamically now add that data to the object. So what I'm going to do is I'm going to refer to this ranking object that we currently have, and I'm going to assign it to a new object. And we're going to add already what's existent in that object to this new object. And then I'm going to create a new key value pair, where the key is going to be a specific name that Algolia requires us to use for geo search to work, which is geoloc. It's an underscore geoloc, and that's the exact name you have to use for the Algolia geo search functionality to work. And inside here, I'm going to pass in the response, which is the response that we get, .data, .results at the specific index of 0, because results happens to be an array, geom geometry.location is the actual response to get that geolocation of this specific point in time. Now, of course, in this case, one thing I did not mention is that the geolocation API that Google has is rate limited. Now it's rate limited to 50 requests per second. Now I'm not going to go ahead and write the whole code for rate limiting your requests, but one easy solution that's a little bit hacky that we can do is we can slice the actual map. So before we map over, we can do .slice like so, start from 0, and then we can, for example, do 300 requests and then go from 300 to 601. But in this case, I'm just going to do like 3 requests just to show you what actually happens. And every time we actually go and call this API, I'm going to console log the ranking. So you can see that we actually are appending data to this specific ranking. So what I'm going to do is I'm going to call get coordinates below. And then I'm going to go into my terminal, stop my current project, run this node project, which is located in this directory and under this name. And if I just run it, what you'll see is that now we get our rankings back. And as you can see, they are ranked differently. They don't go in order because it's an asynchronous call. And we have our geolocation appended to each object, which is a success. And that's the first task done. Now, one thing that we need to still do is if I just remove the console log here, we need to geo universities dot push, and we need to push that data to a new array. So we're going to push the new ranking like so. And what we can do at the end is we can just return that array. So the geo universities array with all those properties. Now we're going to experience a problem here. And we're going to experience a problem where if we do happen to have many requests at the same time, and because they're asynchronous, they might not be completed every single time. And we want to make sure that we iterate over the whole list and everything gets completed. And in this case, we can use promises. We can use promises to make sure that all of these requests actually go through. So I can wrap my iteration in a promise dot all, like so, and wrap it here. And what this will do is this will just make sure that all of those iterations do happen and we won't get any further run issues. Next functionality that we do need to work on is actually saving those GeoUniversities array of objects into a file. Now, because we're going to slice and perform requests at intervals in this case, so I'm going to do 300 calls and I'm going to do 300 calls again, I need to be able to not save to a file, but constantly append that data to a file. So I'm going to create a new function, const generate JSON, basically. And in this case, I'm going to make this generate JSON asynchronous. Now, the reason I want this file to be asynchronous is because I want to make sure that get coordinates completes first and that all of the iterations happen. So to give you an example, if I went ahead and run get coordinates and then I would run generate JSON, which would print something, it would print first and then get coordinates would happen after. So I'm going to make generate JSON an asynchronous function, and I'm going to create a constant called result, and I'm going to await for the get coordinates to complete. And that's a very simple way of managing asynchronous calls to make sure that all that data arrives. Now, the next part is actually saving that data to a JSON. So we can refer to the file system, which I have declared up here, which is the file system of your machine. And here, instead of writing, we can just append a file, which is going to be asynchronous. But for example, we could do synchronous as well. And here, I'm going to firstly insert the name of the new object, which I'm going to call universities.json. And I'm sorry to all the American folks watching this. I know you call universities college, but from the UK, we do call all universities. University is not college. College is a school below. But anyway, that doesn't matter. Let's not get off topic here. The first thing that we enter into the append file sync function is the name of the file that we want to generate. Then we want to call JSON.stringify. to make sure that we stringify that whole request. And I'm going to pass in the result because that result gets returned from the getCoordinates function, and we're awaiting for that result in this case. And the next thing, I want to make sure that I handle all the errors. So we can just pass in the error, and this will become a function where that error gets handled. And I'm going to say if the error basically happens, then we can just throw error. And that's basically it. So now instead of calling getCoordinates, we can call generate JSON. So now if I go ahead and run this generate JSON, what's going to happen? Well, we run our JS file. We can see that it has clearly created university.json, but it's an empty array. And why is it an empty array? And here is the really important part of this kind of lesson. When we're using promises, because it's a promises, we have to await for the promise to complete. Now, in this case, we will have to mark the getCoordinates function as an asynchronous and await for all the promises to complete for all the iterations. And then that will make sure that all the asynchronous calls come through, and what we will get is a file that actually generates data. So if I just delete this and I'll go ahead and run node.js again with the geolocations, if we look at the universities.json now, what you can see is that the ranking is there for that specific object. And then, of course, we're going to get, let's look at for the rankings, ranking 2 and then ranking 3. Now, in order to be able to generate that JSON with all the files, obviously we have to iterate over more data sets. So to be safe, let's do 200 requests just to make sure that we don't get some responses that might not come back because we reached the rate limit. Just so let's be safe and make sure that we do 200. So I'll change that and let's run this JavaScript file again. And here you can see that everything ran correctly. And we've got our universities like so. Now, let me just increment this one more time. Let's make it from 201 to, for example, 400. And let's rerun it. Like so. It appended to the JSON. But there is an issue. There is an issue that's showing us here. And the issue is because we're generating a new array. And this is because of the rate limiting. So every time we're pushing a new array, which kind of ruins the format of this data. So what I can do is just search for a squarely open bracket. And as you can see, here is where the new data starts and the array ends and the new array starts. We can just get rid of this and just replace it with a comma. And that kind of solves this. So I'm going to come back to you guys once I've generated all the data and we can move on. All right, so I iterated over 1,526 objects. I fixed all these little discrepancies within this data. And now I've got this really cool handy dandy tool. So if I just copy everything, I've got this online JSON viewer where you can paste all of this and you can actually format all of this JSON to make it much nicer and much more visually appealing. Now, in this case, I'm going to copy all of this data and I'm going to delete all of this and paste all of this data in, just to make it much nicer and much more visually appealing. So now we actually have all the records of all those universities that are ranked, with every single university having a geolocation that we're going to use to actually implement within that geo search map for Algolia. So here is the final universities.json file that we're going to use. So now we can actually move on to pushing that data to Algolia and creating a new project and then generating a new index. So let me show you how to do that. So if we go onto Algolia, and I have registered on it, under applications, you'll be able to create a new application. Now, if you're new to Algolia, it'll kind of guide you through that whole process. But in this case, I'm going to show you how you can create an application if you want to go on and create another one, or if you just register, skip the whole tutorial and you just want to dive into following my way of doing it. So here I'm going to create an application, but in this case, let's just call it university-rankings, like so, university rankings. Now I'm going to go on the free version because it's quite a small project just for showcase reasons. And I'm going to go to the next step, which is the data center. Now I'm going to select the region that I want to use. And in this case, because I'm from the United Kingdom, I'll just go directly with United Kingdom. It's quite fast here. You can see the loading times as the estimated response from the United Kingdom. So it's quite fast. 23 milliseconds is good. Review my application. And then I want to read and accept the terms and conditions and create my application. Okay, security question, bicycles. Well, here is the bicycle, and let's go next. Crosswalks. Oh, wow. This is making me do a lot of verifying. I guess it doesn't trust me. Okay, and the application is being created. Okay, so you can either click you're new to Algolia or you are an experienced user. Well, if you're new to this, make sure you just click and go through that tutorial. It's about 10 minutes, as they say. So I will explain how Algolia works. Because I'm an experienced user and I want to dive right into everything, I'm just going to select experienced user. Okay, and here it's generating the dashboards. Now, we have our university rankings, which is our application. And here I'm going to go onto the search. Now, search is a place where you will create an index and you'll upload all your data. So in this case, we'll upload all our JSON. So I'm going to create an index, which will be the name of the index that we're going to refer to in our code. And I'm going to say university city rankings 2021. And I'm going to create this specific index. Now that I created my index, as you can see, it's very simple to use. I want to upload my records. So I'm going to click on upload records and I'm going to upload the file, which is the JSON file. And I'm going to go onto my files, go into the Webpack starter. And here I can find the university.json file that we created programmatically with all the geolocations. So I'm going to select this file and I just opened it. No, I want to quit. You don't have to open it. You can just directly drag it into Algolia like this and click upload. Now what this is going to do is you're uploading all that JSON information to Algolia so it can process it super fast. And well, I can configure searchable attributes and configure ranking. Actually, let's do that straight away so you will understand what is going on. So let's configure. So the searchable attributes are the attributes that we're going to search by. Now, if I go into browse, and you will be able to see here, right here we have a specific university, which is the ranked as 1,501 in the world. It's in Lithuania. And we've got all these kind of attributes. So when we're searching for a university, we definitely want to search by the title. We definitely want to search by the location, and possibly we might want to search by the ranking, but let's just focus on title and location. So I'm going to go into configuration like we did before, and I'm going to add a searchable attribute. And the searchable attribute already pre-populates all the attributes that you have available. And one of them is going to be location. And the other attribute is going to be the title, which is the title of the actual university. And just to make sure, I'm going to review and save the settings like so. And I'm just going to make sure that it's actually called title. And it is called title. So we are all good. So we've configured searchable attributes. And this is what we're going to be able to search by in our application. Now, when it comes to ranking and sorting, I definitely want to rank each search by the ranking, the university ranking. So if I type in universities in London, or if I type in the location London, I want to have my first search result as the university that ranks highest in London. And I want to rank it by the ascending order. So from lowest to highest in this case. And I'm going to review and save. Now, Algolia is awesome enough to know that the ranking is the ranking, that it sorts by number, if it's a number or a string or whatnot. So this is all set up. And we've completed all the tasks. So now we can actually go back into our code and start writing the UI to make this all visual and to make this all work. All right, so let's jump right into the code to actually create this UI. So instead of what we have here right now, let's create the UI and actually make everything work. So I'm going to jump right into here. I'm going to get rid of this JSON file. We don't need this anymore. We can close the geolocations. And I'm going to jump right into the starter. Now in this starter, we don't need to import this image like so I can get rid of this. And nor we need to return all these things right here. So I'm just going to actually delete that like so. And in this case, I'm just going to declare this as a class name of wrapper, which is basically going to be the wrapper for our whole page. Now, let me just copy over all the imports that are necessary for Algolia. And we need to install all of these locally on our machine. So we can just do npm install Algolia search. We need to install react.instance search DOM. This is specifically for using React, and install the React instance search DOM maps to be able to kind of use the Algolia already implemented maps. And I want to search this into the development dependencies. So let that install, and I'm going to come back to you when it's complete. Okay, so the applications have successfully finished installing, and we are good to go. So I'm just going to clear this just for it to be fresh, and we can start developing the starter. So if we look back at the page, and I'll just refresh it. Oh no, actually, let me just, we need to run npm run dev, like so. It'll probably open up in a new window, so I can just close this one. And we will have just a blank screen. Nothing here because we've just cleared everything. So we're good to go. So the first thing that comes with Algolia, and I'm also going to just copy it over my other screen, is authenticated to that specific index. Now here we create a client, and we need to pass in our public API key, and that's the wrong one. And I'm going to show you how to get that just in a second. And we need to pass in our index, I think it's called an index code. We'll just double check that right in a second. So the way you can find those, if you just go back to Algolia, if we just click on home here on the overview, we are in our university rankings application, and we can click on our API keys. And here we have our search only API key, which is a public API key. So I'm just going to copy this to clipboard, and I'm going to paste it right in the space of here. And then we have our application ID. This is the application ID that we also need to copy over to know that we're making use of this current application. And that is all the kind of search client setup that we need to do. Now, because we're using Google Maps, I need to declare my Google Map API key. So API key, and I'm actually, instead of writing this, I'm going to copy it over, and I'm going to show you what I'm actually implementing into here. So I've got my public API key for my Google Maps. I've got the endpoint for the generic maps that we want to use. I've got my initial zoom that I will want to include on my maps, and I've set my initial position. And these will actually be very handy when we go to implement the maps. So just bear with me. Instead of writing it out, it's just easier for me to include all of this right here. Now, instead of a constant starter, let's just call it search, and we can export default search here. And now we need to focus on some specific things. So as you saw previously, the generic idea on the page was that we split the page in half. Here we have all the search stuff, and here we have the map. So this is exactly what we're going to do. So I've separated everything into wrapper, and inside this wrapper, we're going to wrap everything in the Algolia instant search block. And this instant search block takes two things. It takes the index name of the current index that we're working with. And as you can remember, the current index that we are working with, if I just go into the search, is the University Rankings 2021. So university underscore rankings underscore 2021. And the other thing that the instant search takes into account is the search client, which is, in this case, the search client. So pretty self-explanatory that we declared up above with all our credentials. Now inside this instant search, I'm going to create two divs and give them class names. One of the class names will be called search and hits, which is basically going to be the search input box and all the kind of results that we get. So I'm just going to close this div. And the other div that we're going to work with is going to be called map, which is going to be pretty self-explanatory as the map that we're working with. With Algolia, it's very easy to generate the search bar and the hits because Algolia already has pre-existing built-in widgets, which then you can kind of style and adjust for yourself. But in this case, what I want to do is I want to import the Algolia search box, which we previously declared up above, right here. And we want to pass in the hits. So now if I actually go into our project and I'll refresh, what you can see is we already have a search box and we have all our universities that are being ranked from number 1 all the way down. And we have 20 results per page. Now, if I type in London here, you can see how instant it is. If I type in India here, that's the universities. If I want to type in my university of Kent, well, there you go. That's the university. So the filtering is simple and is super fast. So the filtering is super fast. And as you can clearly see, the widgets, it's just working. It's so quick and easy to implement with Algolia, things that are technically quite complex because they already do all the hard stuff for you. So let's go back and let's continue. Now with our search and our hits, obviously we want to render very specific stuff. So we can create our own kind of hit component, which will return the things that we require. So I'm going to create a new component called hit, and it's going to be a function that will take the hits. And here we're going to have a fat arrow function, and I'm going to wrap this in div called and give it a class name of hit, like so. And inside here, I'm going to create 3 p tags, and each p tag I'm going to say world ranking and give it a number, and I'm going to refer to hits.title. Now let me just copy this over again and paste it in 2 more times. So we're going to have the title on each ranking. That's what we want to display. We want to display the location, and here we're going to have location, and we want to display the title. So name, I'm just going to say name, and we're going to have title. And in this case, sorry, world ranking, I put title. I don't know why I did that. I wanted to mention ranking. So here, what we can now do, and the way you specify this, custom hit or custom things that you want to display, inside the hits component that's already inbuilt into Algolia, we can specify a hit component as a property. And what we can do is we can pass in hit right here. I've made a mistake because hit doesn't take hits, but just takes a specific hit. So let's just rectify this. And there's also another mistake because it's a hit component. And one final thing is here I wrapped it in an actual curly brackets. We just want to do open brackets like so, because we need to be returning each hit rather than kind of providing a new one. So now what it should do, there we go. So it already automatically refreshed. And now we can see that, it still comes back as bullet points because it's not styled, but we have the world ranking, the location, and the university name. So if I just type in Oxford, for example, obviously it renders 2 rankings right here. Okay, so now we are at the point where we can actually start rendering a map. So if we go back to our code, we've got the search box, we've got our specific hits, which we're kind of adjusting to the way we want to showcase it in the web. And now we're going to focus on the map. Now, the cool thing about Algolia is that they already have all these widgets on their website. So if I actually go onto the geo search, Algolia geo search, and it's the component that we're going to use for React in this case, they have code examples. So if we just scroll down a little bit, you can see that they give you the specific import, and they also give you the Google Maps loader. Now, as you can see here, for this Google Maps loader, they're wrapping the loader in a div, which has a height of 500. So before I go ahead and copy this, I'm going to create my own component that's going to act as a wrapper. So it's going to be like a container wrapper. So if I just jump back into the code and go below hits right here, I'm going to declare a container, which is basically going to take, in the curly braces, some children. So the properties are going to be children. And it's going to return, so make sure that it's normal brackets instead of curly brackets, a div, which is going to have a class name of container. And I'm going to, inside this container, I'm going to pass in the props called children. And that is basically that container complete. So if I just run back to the map, I can directly here pass in the container, like so. And then now we have a wrapper for the map object. Now what I can do is we can just go ahead and directly copy this map loader, which will save us a little bit of time because obviously we want to be very time efficient when doing all these things. So I'll just implement it here, and here we pass in the API key. Now, as you remember previously, I've already declared the API key here, so we can just copy and paste this in. And the other thing that we're going to paste in is the endpoint. The endpoint of that specific Google Maps map that we want to use, and I've already declared it here, and we can pass into the endpoint. This geo search component here takes Google as the kind of property, but we can also refer some other properties. So this is the map property that Algolia provides. And here we can specify an initial zoom, which I have declared here as the initial zoom. Oh, that was supposed to be inside the curly braces, initial zoom. And we can also declare the initial position as the previously declared initial position, which are right here. So the zoom is set to 20 and the initial position is set to some random latitude, longitude, just so it doesn't render like in the middle of the sea or something. There we go. So we have declared our geo search, and then we can go ahead and declare our hits. So our hits are basically the markers that we're going to render. But instead of this being a div, I'm just going to create it and make it a fragment. If you're unaware of what a fragment is in React, and this is a shortcut of writing it, the full version would be like this, fragment and fragment, but we're not going to use that. We're just going to use the shortcut, and it basically allows you to render multiple children as a main component rather than multiple children nested in a component. So this is basically how it works. Now here, we don't need to declare a control component that Algolia offers, but what we do want to do is here we iterate over hits.map with each specific hit, and we mark that key as the hit.objectID and the hit as hit. Now, because we previously created our JSON with the geo_geoloc key, with given values of the latitude and longitude, this will just literally work out of the box. So if I go back to our project, if I refresh, if I just scroll down, and we don't have the map. Oh, right. Okay, so I forgot, because we obviously have to provide a height to this map for it to actually display. Let's jump right into the actual CSS to showcase all these results and to validate that it actually works. So you can just jump right into the starter. Here we don't need the page wrapper. We have declared our main component as wrapper, so I can just delete everything else and we can start building out our UI. So one thing I think that's important is that we set the width as 100%, and we set the height as 100 viewport height, so it just covers most of the screen. But we also want to give this project a padding of 20 pixels just to kind of keep it in frame, and we want it to display flex, so everything kind of will automatically display in a row rather than a column. Now, of course, with this height, we want to calculate some things because we have the padding, so we need to minus the padding from the left and the right side, and also we need to calculate and minus the padding from the top and the bottom, double 20 pixels, which is 40. Now, of course, because as we can remember, here we render the search and we render the hits, you can inspect this kind of block right here and look up the actual class. In this case, it's the AIS-searchbox-input class that refers to this search box. And we can just directly declare it, and that's how you can look up the classes of all these pre-written widgets that Algolia provides. And here we can actually specify that we want this to be width of 50%, so half of the screen. We want this, this is the search input. The search input, if we just remember, the search input comes inside the search and hits div. So let's declare the search and hits div like so, and this comes right inside it because we're using SCSS. Of course, we have that nesting. So we can declare the search and hits as being the width of 50%, so cover half of the screen. We want the height to be 100%. And then obviously anything that kind of scrolls over, because we're going to get a lot of results, we want an overflow Y of scroll. So we just want to make it scrollable rather than overflow. Now we can refer to that input box and we can say that the width of the input box is going to be 100% of that 50% width. But of course, there's going to be some discrepancies, which I guess we'll fix in just a second. Let's make the height 50 pixels. Let's give it a border. So border of 1px pixel solid, and let's give it an RGB value, which is going to be black, but with an opacity of 0.1. Let's give it padding of 15 pixels. Let's give it a font size of 20 pixels and a font family. And I really like this font. It's called Muli with a sans serif kind of font to go to if the Muli font is not available. So there we go. So if we just go back to our actual search, now you can see that we have our search, which is covering 50% of the screen. And of course, we can also scroll. But as you can see here, this search bar is actually going to the very end of the scroll, whereas we have a 20 pixel kind of space right there. We also, I believe, have a default margin and padding everywhere. So do is declare the body element and say that the margin, oops, not the max resolution, but margin is equal to 0 and that the padding is equal to 0. That will fix some of the defaults. And here what we can say is that the width of the search box is 100% minus 20 pixels, which is the padding. So it looks like it's symmetrical from both sides. And as you can see, there we go. We fixed the padding here. Obviously now they're equal and we have that space right there next to the search box. Now this is a search button that's not needed because it automatically already searches. And then we also have this close button that we don't need. Because I already am aware of the classes, I'm just going to add them. So we're going to be referring to the button dot AIS search box submit button. And we're going to give this a display of none. And we will also be referring to the button. Let me just scroll down a little bit. Dot AIS dash search box reset. And we're also going to give this a display of none. And of course, if we want to make this look a little bit nicer, we can just refer to both classes like this. And we can get rid of that. So now if we go back to our project and have a look, we don't have the clear button, but it just automatically appears right there with Algolia, which is quite nice. Now, before we continue with all the styling here, let's just get the map implemented and styled so we actually can see what is happening. So if we refer back to here, we've got the class name of map for that specific div, and that's what we're going to be working on. So let's go back to our SCSS, and we can see that search and hits is here. So just below search and hits, because they're at the same level, we have our map class. Now with our map class, let's give it a width also of 50%. So we know that it covers half of the screen. Within map, we have to now refer to the Google Maps loader and the geo search components and adjust their kind of widths as well to make sure that all the styling is correct. So as you remember previously, we created a container that was a main wrapper with a class name of container. So we can refer to that. So we can refer to the container, which is basically setting the width of that map. So it actually shows up, and let's give it a width, in this case of 100%, because it's the child of the map parent, and a height of 100%. And inside this container, we have the Google Maps loader and the geo search, and the classes of those are AIS-geo search. And inside here, we have the AIS-geo search-map. So the AIS geo search is going to have a height of 100%, and the AIS geo search map is going to have a height of 100% and a width of 100%. And that's just kind of, it's a bit ugly, but that's how it works to actually get the styling to work. And there you go. Voila, we've got the map appearing. So now if I go ahead and like I did previously, type Poland, look at that. And it just highlights on the Poland and it takes up a lot of the screen. So now this is our map styling done. We can go ahead and finalize the styling and making it look all nice and pretty. So if we jump back into the code and we jump back into the starter, we can see that all of those hits that we generated here have a class name of hit. And also we have the paragraph text that we render. So those are the last kind of CSS that we need to add for it to look good. So the hits that we render are right inside the search and hits. So we have the search and hits kind of class here, and inside it, we'll refer to the hit class. And for the hit class, we're going to give each one a width of 100%. We're going to give it a padding of 10 pixels from the top and the bottom and 20 pixels from left and right. Let's give it also a font family of Muli with a fallback to sans serif. Let's give it a font weight. Let's just make them bold. Let's give the background boxes a color, and I really like the color, which is F4, F5, FF. It's like a nice bluey grayish. And let's set the text color to not directly black, but a color I really like, which is kind of a black gray. Now let's see what it looks like. Well, we can see that, okay, we have the boxes. Clearly they are overflowing. Oops. Clearly they are overflowing if we inspect them like so. And we still have them as an unordered list. So we need to make sure that we fix that. So the way to fix it is that we can give a margin bottom of, let's say, 20 pixels. And we can improve the width by calculating it and minusing, let's say, I think it was 60 pixels to make them fall into place. So yes, so to make them equal with the search bar. So there you go. But the last thing that we kind of want to do is remove these bullet points. Inside the hits, we can refer to the actual class within Algolia, which is AIS hits. And here we can directly refer to the AIS-hits list and give this a list style type, not disk, but none. And also we can set the padding to 0. So if now I return back into our code and I will refresh. Okay, so it seems like list style tab. Did I do a typo? List style AIS hits. Oh, okay, I see what we did wrong. So AIS hits is not inside the hit class. So it's at the same level. That's why it wasn't showing up. So now if we go back, and there you go. And we have our search rankings nicely styled like so to appear. So now if I go ahead and search for Poland one more time, or if I search for India one more time, or if I search for the United States, like so, everything pops up, and as you can see, the rankings are ordered and everything is nice. Now, the project doesn't end here. There is so many other widgets and functionality that Algolia offers to really enhance user searching experience. And I would love to see some of you guys be brave enough to take up this challenge and try and implement some of the other widgets into the current project, or when you create your own project with a completely different data set and find ways to search through the data that is much more interesting and maybe much more convenient to the user. Now, some of the things I do want to share with you today is, for example, the menu select widget that Algolia offers. Now, this, instead of a search input box, you have a dropdown. So if you recall to the data that we had, for example, we could create a dropdown for all the specific countries. And for example, if I were to click on London, it would search for London. In this case, we have different tech companies, but of course it would work in the same way for countries. The other really cool widget that they offer is the rating menu. Now, this allows you to search for results based on the number of stars. So you could have a whole data set of, for example, products which were rated and reviewed, and you could search by products, which is a very common case. You could be more creative, and for example, if you remember our JSON, you could append to every object of each university, maybe the student satisfaction, and map that student satisfaction to a particular number of stars, and maybe you could search for like that. So the options are limitless. The other widget that I really want to show you, and it's the highlight component. And now the highlight component, basically, whatever you search, it will highlight the words that you searched for within the search result. So, for example, if I search for amazing, there you go, it found the word amazing and it highlighted it. I could search for the word cool. And yeah, it did find a cooler. So yeah, Algolia has so many of these amazing instant search functionalities and widgets, as you can see on the left here. So I really encourage you to explore and be brave enough to try integrate your own dataset with your own functionality and make the most of it. I really hope you guys learned a ton. I hope you guys were able to follow through the whole tutorial and you really learned and understood how Algolia works and how the whole project works, and learned new things on how to manipulate data, maybe do API requests, or maybe just work with Algolia directly. So thank you very much for watching, guys. If you did enjoy projects like this and you want to see more, make sure you smash the thumbs up button and make sure you subscribe to my channel to learn more about really cool web development, really cool tools, and just making things look nice and beautiful and so on. So thank you very much for watching. I hope you guys enjoyed, and I'll see you in the next video. Peace.